Alright, in this session we're going to talk about chemical reactions. Now, this is going to be the first time that we've done this, and so I want to make sure we understand what's going on. Up to this point we've talked about all the elements on the periodic table. We've talked about how to take ionic compounds, things from the left of the chart, and put them with things on the right of the chart, and how we get different compounds. Matter of fact, in our last lesson we talked about sometimes you can take two things on the right, like carbon and oxygen, and you can get CO for carbon monoxide or CO2 for carbon dioxide, and there's no charges in that. They just plug into each other like Legos. But that's not the only thing that happens in the world. We don't just have elements and compounds. The really cool part of chemistry is chemical reactions. And so we're going to talk about first the parts of a chemical reaction. Now, here's an example of a chemical reaction that all of us know. Iron, which is a solid, and oxygen gas. Now you'll notice there's a little 2 there. There's some elements on the periodic table that show up in twins. You don't have to worry about which ones, but that's what that little 2 is. It's found in twins or pairs. It's called diatomic. You don't have to know that word, but there it is. You have iron and you have oxygen. And then on this other side, they will combine to make rust. Just like your car or your bicycle rusts over time, the iron and the oxygen react to make rust. And we're going to talk about for a minute what the parts of a reaction are, and then we're going to talk about how the reactions actually take place. Well, first, let's do this. The left-hand side of a reaction are called the reactants. The reactants. The right side of the chemical reaction are called the products. And here's how it works. The reactants are what are reacting. The products are what are produced. The arrow in the middle right here is called the yield sign. Sounds like a yield sign when you're driving your car. So reactants yield products. And that's how, those are the two sides of a reaction. So the reactants, that's all of this, yield the products. So in this case, there's 2 reactants and there's 1 product that is made. Now inside a reaction, there's all kinds of things that can be written down. Now we've already learned these are the symbols of the elements, so we won't label those. But the little S's and G's, these are called the phase. S is solid. Just go ahead and write these down. S is solid. L is liquid. There's not one of those in this example. G is gas. And sometimes you'll see this one called AQ, and it is aqueous. I'll go ahead and define that. It means dissolved in water. Dissolved in water. Now that can be a little bit confusing for you because that almost seems like a liquid. Let me explain the difference. Sugar, when you go into your kitchen, sugar is a solid. But we don't always use sugar in solid form. When I want sweet tea, I will take it and drop it into my tea and mix it up. Now it's aqueous. It's been dissolved into water. If I wanted liquid sugar, then what I would do is I would throw that sugar in a pan and set it on the oven and heat it up, and that's when it's a liquid, when it melts. So that's the difference between the two of them. L is liquid, AQ is aqueous. I'm going to erase these definitions, so if you didn't write them down, you may want to pause real quick and write these down. All right, so let's label a little bit more. So we have phases: solid, gas, solid. Let's see, the next thing, these little numbers, I think I've given you this word before, but I'm going to go ahead and give it to you again. It's called a subscript. Subscript. Anytime you have little numbers, they're called subscripts. So there's a 2 there, there's a subscript, there's a 2, and there's a 3. So those are all subscripts. Also, I'm going to change colors real quick. You're going to find that reactions also have big numbers written in them. I'm going to do a little erasing to give myself some room. In the next session, we're going to talk about where these come from, but you're going to see sometimes these really big numbers like this in front. These big numbers are called coefficients. And all a coefficient really is it tells me how many. So in this case, it takes 4 of these with 3 of these to make 2 of those. We'll see that more here in a minute, but that's what it is. Okay, so we have coefficients. We have subscripts, phase. The last thing, and I need to erase this word here, you probably know that whenever you have a car and it's going to rust, it's usually because the metal continues to get really, really wet. And so water causes rust. Now, sometimes in a reaction, you'll see something written above the arrow, just every once in a while. That is called a catalyst. That is a catalyst. And a catalyst is used to speed up or slow down a reaction. See if this makes sense. If I want to keep my car from rusting so fast, then I need to keep it dry, because when there's water around, it makes it rust faster. So it speeds up the reaction. It's called a catalyst. Now, anytime you see a reaction, if there's something written above it, then that is called a catalyst. Now, let me give you an example that you've probably seen before. One more reaction, and it looks like this. Carbon dioxide and water yield glucose. That's a really big compound in the presence of sunlight. Now let's talk about this one for a second. Carbon dioxide and water produce sugar in the presence of sunlight. This is what plants do. This is what is called photosynthesis. Photosynthesis. If you watched all the videos up until this point, this is what takes place because we have chlorophyll in plants, and the chlorophyll is inside the chloroplasts. So there is a little bit of chemistry in your biology class. Well, let's explain. You and I breathe out carbon dioxide all the time. And plants take in water, and they produce sugar, and they also produce for us, add that to the end of the reaction, oxygen. So that's why plants are so important to us, because they breathe in carbon dioxide, they get carbon dioxide from the air, water from the soil, sitting in sunlight, make glucose, and make the oxygen that you and I need to breathe. That is called photosynthesis. The interesting thing about this reaction is it can actually be turned around. You and I do the opposite. We eat things that have glucose in them, simple sugars. We breathe in oxygen. We don't need sunlight for us. And we produce carbon dioxide that we breathe, and we produce water. Okay? And we sweat water out of us, and we produce water. This is actually, notice the arrows go both ways. This is what is called reversible. And there's only a few reactions in the world that are reversible. There's some. There's just not lots and lots of them. And so this reaction can go this way. It's called photosynthesis. And this way is called respiration. And they like to ask that question on the tax test every once in a while because it's biology and chemistry together. Now let me ask you a quick question. Do you think this reaction is reversible? Iron and oxygen making rust. Can you take a rusty car and get all the good metal back? Nope, you can't. That's why there's only a single arrow. It cannot go back this way. It only goes one way. So some reactions only go one way. Some can actually go both ways. Now, this reaction still has all the same parts. These are the reactants. These are the products. So the arrow always points to the products. If we make the reaction go this way, then it reverses. These would be the reactants pointing to the products because that's what we were making. So some reactions go both ways. It's called reversible. This reaction only goes one way. Now you know the parts of a reaction. In the next section, we're going to talk about where all these big numbers come from and how do you get them.